Thank you, Gunna, and welcome everybody. Today we will look at something different, something more interesting, in the sense we will connect the same lamp as we did before to the same power supply and measure the current using the same multimeter. But before we connect the lamp, we will measure the resistance of the lamp. And the lamp has a tiny wire, thin wire made of tungsten called also wolfram. Tungsten comes from the Swedish word tungsten, that means heavy stone. Now we measure the resistance at the room temperature, and in our case we will see that R at the room temperature 0 is, at the room temperature resistance is R0. In our case we will see that it is about 38 ohm. Fine. Now when we connect it and to a power supply and have a voltage, let's say 10 ampere, 10 volt, then we will see the current from the display of the amperometer, and then Ohm's law, voltage is equal to current into resistance, or resistance is equal to voltage by current. Now let us say we take 10 volt and we will read the current from the display, let's say I ampere. When we divide 10 volt by the current that we read here, we will notice that according to Ohm's law, the value we will get here will be different from this. Will be different from this. And if we increase the voltage from 10 to 20 volt, and the current that we will get again, let's say 2 ampere, we will see that the resistance will be even greater. If this is 38, this will be greater than 38. This will be still greater than 38. Now why? Does it mean that Ohm's law is not appropriate? No, that's not the case. Ohm's law is of course true. What happens here, that the resistance changes. The resistance changes because as we increase the voltage, current decreases. Why? Because the resistance of the lamp increases because of the heating. The tungsten or wolfram has a melting point of about 3,400 plus, more than 3,000 degrees Celsius. Until then, the resistance changes as a function of R0 plus R0 plus 1 alpha is the temperature coefficient, T minus T0. So R0 is the resistance of the lamp at temperature T0. Alpha is the temperature coefficient, and for wolfram, alpha for wolfram is equal to 0.0045 per degree Celsius. So if we know the resistance at room temperature, and this is the room temperature, we know alpha, then we can find out the resistance at a given temperature. Or if we want to find out the temperature, what is the temperature of the lamp when the voltage is 30 volt, when the voltage from the battery is 30 volt. So when the voltage is 30, we can measure the current at that voltage. So you know the voltage, we know the current, then we find out R. That is, we find out RT. Now if we know RT, we know R0 at temperature T0, which is our room temperature. At room temperature, this was 38 ohm. Alpha is known, then we can calculate the temperature. How do we do that? Well, our equation, when we rewrite that equation, we can write it as 1 plus alpha T minus T0 is equal to RT divided by R0. Or alpha into T minus T0 is equal to RT divided by R0 minus 1, or RT minus R0 divided by R0. Or T minus T0 is equal to RT minus R0 divided by alpha R0. Or T is equal to RT minus R0 divided by alpha into R0 plus T0. So we see that if we know the resistance at a unknown temperature, and this was what we knew before at room temperature, and alpha for Wolfram is also known to us, then we can calculate the temperature. So the lamp can be used as a sensor to measure temperature. So to summarize, we need to remember that when we are working with metallic resistance, then they are very sensitive to temperature. As the temperature increases, the resistance also increases, because there will be more free electrons that make a crowded condition. So the resistance to electron flow increases, and it is in fact the electron flow that is current. So using this principle that resistance changes with temperature, we can use a metallic wire as a temperature sensor, and accordingly we can calculate the temperature. Now we will demonstrate how that happens. Thank you.